So we are going to look at our place in the universe here. And I remember as a kid seeing these activities where you would try to list your address. And you would go as precise and as broad as possible. And so, for example, you could list your seat in my classroom, and I'm room, I think, C127 in the school building. And that's at Russia Local School, 100 School Street, Russia. Let's go Shelby County before we say Ohio. We could even go township before that, but I don't know what it is. And then or maybe we say Shelby County, Miami Valley, Ohio, and then United States, North America, the Northern Hemisphere and Western Hemisphere, the Earth, the solar system, and so on and so forth. And you could just keep going out and out, pinpointing your location. And that's kind of what we're going to do here is go through what is our actual place in the universe. Now, one big thing I want to point out here is that anytime you see pictures of anything like this outside of our solar system, it is probably a artist illustration. Not probably. It is an artist illustration. We have never taken a picture of our own galaxy because we're on the inside looking out, and to get out to this distance would take hundreds, thousands of light years to get to. And some of these places we could never get to. And so instead, it's kind of awkward, but we are in one location and we are studying our place from inside of the thing that we are in. We're still fairly confident about all of these discoveries, but we are on the inside looking out and not the other way. We will, however, get to the point that we're actually going to start out and zoom our way in. We will get to the point where we do get to actual photos of our solar system and of the Earth from space, and just some of the awesome things that we can see and learn with that. And you'll get to see a whole bunch of my favorite space imagery here. So let's get on with the notes part of things. So first off, our cosmic address. First off, we are part of the universe. The universe, uni means one versus, I sort of guess just what we are, what we call it, but it's everything, all of space, all of time, all of matter. I know I don't have time listed there, but it's all of space, all of time, and everything in it. It include all the energy in our universe, etc., etc. It is all the stuff. There are theories out there that there could be multiverses, which is kind of a play on words because uni means all of it, and we'd be dealing with something that's outside of the universe, but no evidence that multiverses exist. There's even competing theories about what a multiverse could be if it did exist, and most theories say that the multiverses probably don't interact with our own universe. And if they don't interact with our universe, what's it matter if there's other universes out there if we can't ever detect them? So anyway, we're not going to worry about that. We're going to pretend that our universe is the only one, whether it is or not, and go on from there. Anyway, within the universe, there are lots of superclusters, which are large groups of galaxies. We are part of the Virgo supercluster, and that's named after the constellation that you are looking through when you look towards the center of the supercluster of galaxies that we're a part of. Within the supercluster, there are a whole bunch of groups of galaxies, and ours is creatively named the local group, which is a small group of galaxies. Our local group or galactic group consists of about 30 galaxies. You could argue that it's more if you start to count a lot of star clusters, globular and open clusters as instead dwarf galaxies, in which case there could be hundreds, but it kind of just depends on how you want to define it. The big thing is there are only two large galaxies, Andromeda, which is 2 to 4 times larger than us, depending on what measurement you're using for size, and our own Milky Way. The Milky Way is the galaxy where we are, and you can see a part of the Milky Way at night. When we talk about seeing the Milky Way, you're really just looking at an arm of the Milky Way, and I'll point that out on a picture here in just a moment. But galaxies are large collections of stars, gas, and dust in space. Our Milky Way galaxy has between 125 and 500 billion stars. I like the 500 billion just because, one, it makes it sound bigger, and two, it makes a lot of the math that I do in my head easier when I consider it that way, but it probably is on the lower side of that. And then there are fragments of arms. When I was in high school, we thought there were 4 spiral arms, and it turns out there's only 2 spiral arms, and we're a barred spiral galaxy. And I'll point out what all that means here in a moment, but we are, instead of on the Orion arm, we are on Orion's spur, which is just an arm fragment. Within the Orion Spur, then, is our sun, which is it's the center of the solar system. And the solar system is our sun and all the objects that orbit around it, including the 8 planets and the numerous dwarf planets and other small bodies. And of course, inside of that is the Earth, which is the planet that's our home. And we studied quite a bit back when you're in 8th grade. And if you want more, take geology with me in the future. Anyway, feel free to pause, back up, and take more time on those notes if you need it, but we're going to move on here into some images for a bit. So here is a artist conception of the universe, putting the Virgo supercluster at the center. Interestingly, because there's a limit as to how far out we can see, because the universe has a finite age, and so then there's a limit as a time limit that it takes light to get back to us. There's a limit as to how far away we can see, and so we can imagine ourselves to be at the center of the universe even if we aren't actually. And so then anyway, this is every one of these dots here is a supercluster of galaxies, and a Virgo supercluster is there at the center. This here is a zoom in on some of the superclusters, and again, Virgo supercluster here at the center. And most of these clusters here are named after the regions that you're looking through, the different constellations you're looking through to see those clusters of galaxies. Within the Virgo supercluster is a local group made up of, as I said, Andromeda, a large, it's a ring galaxy, actually, a spiral galaxy that's been distorted, but a ring galaxy, the Milky Way galaxy, which is again what we're part of, and Triangulum, a whole bunch of dwarf galaxies orbiting in what are called the galactic halo, kind of a cloud around the galaxy. The biggest two of which, near the Milky Way at least, are the Large and Small Magellanic Clouds, and the Magellanic Clouds and Andromeda here actually appear to be photos to me that they've resized to be appropriate size. But of course, the Milky Way here has to be an artist's conception. But anyway, Large and Small Magellanic Clouds named after Ferdinand Magellan, the first Westerner to discover them, or at least to record them when he sailed around the world. Southern Hemisphere doesn't have as many constellations as we do, but they have a little bit, they have a different part of the Milky Way they can see, and they can see those 2 large clouds, which also help to make the night sky a little bit brighter and obscure out some of the other stars that otherwise would be bright. And anyway, moving on. The Milky Way galaxy, as I said a moment ago, is a barred spiral galaxy. There's this bar here at the center, and that was actually discovered by the Spitzer Space Telescope, which looked in the infrared. But interestingly, the center of the galaxy, of most galaxies, is so filled with gas and dust that actually blocks our view of the back side here. And so we actually don't know about a lot of this wedge back here. It's inferred. So for example, one of the 2 major star arms here is the Sectum Centaurus arm, and we can see it coming out here, and then we stop being able to see it when it gets obscured by the bar, but then we see this tail end out here. And so we can extrapolate and assume, maybe it's interpolate there would be the better term, but and assume that this arm is one continuous arm, and so on. Anyway, we used to think we had no bar and that we had 4 spiral arms, but again, we are instead on the Orion Spur instead of the Orion arm, and there is the region where our sun is. Of course, that circle is not our sun, it's way too big. That circle is even larger than the area around our sun that we've explored. It might be about the right size for how far away our first radio signals have gotten away from the Earth. Anyway, here we are getting to actual photos though. So as we zoom in on our solar system, this here on top is the first solar system family portrait that was ever taken. Carl Sagan realized as Voyager 1 was leaving the solar system that it could turn around and take a photo and or take a series of photos and get almost everything in our solar system picked up there. And so he convinced NASA that this would be a worthwhile effort, because on the Voyagers we had these golden records that were essentially messages to aliens, but I would describe them more as time capsules of us, that the odds of any aliens ever getting it are so low that it's more of something that we wanted to make a statement about ourselves. And so he argued that that was one of the goals of these Voyager missions, was to help us understand our place. And Voyager 1 and 2 went to Jupiter and Saturn, both of them. We had two spacecraft go to Jupiter and Saturn before that. The Pioneers 10 and 11 did that. Voyager 2 went on to see Uranus and Neptune. Voyager 1 was on a different path that took it up out of the plane of our solar system, but then that gave it the advantage where it could do this solar system family portrait. So they took a series of 60 photos when it was about out at the orbit of Pluto, 40 astronomical units, 40 times the Earth-Sun distance. And it took these series of photos. And then in this photo was Neptune. And here we had Uranus and then Saturn and so on. And right there, and we'll get a closer look at that one here in just a moment, is Earth. Now, the planets aren't in quite the right order here as what you're used to thinking of them because, of course, they're going around the sun. The two planets that are missing here, Mercury was too close to the sun and they're afraid of damaging the camera if they try to catch Mercury, and Mars was on the backside of the sun, so it was not visible here at this time. Later on in 2010, we kind of did the same thing with the Messenger spacecraft, except we started at the inside and looked out. And so it did this with 34 photos that it took before it went and orbited Mercury. It was our first spacecraft to orbit Mercury. But then from there, again, you can see Saturn, Mercury, Mars, Neptune, Jupiter. That one there should be Venus. It's hidden by the stupid icon here. And then Earth and the Moon. And the moon dot is really faint there, but is actually visible if you look at the blow up. And I don't think I have the zoomed in version here. But I do want to take a moment here before I run out of time and have you look again at that dot that is the Earth right here. Seriously, in the original photo, and this is blown up, it was one whole pixel, one dot. And the rest of what you're seeing here is dust that orbits the sun with us, and the sun is lighting up that dust. But I want to read to you the words of Carl Sagan that he wrote about this when presenting the image. And then later on, he wrote a book of the same title, A Pale Blue Dot. Look again at that dot. That's here. That's home. That's us. On it, everyone you have ever everyone you love, everyone you know, everyone you have ever heard of, every human being who ever was lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilizations, every king and every peasant, every young couple in love, every mother and father, hopeful child, inventor, explorer, every teacher of morals, every corrupt politician, every quote superstar, every quote supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the endless cruelties visited of inhabitants on one corner of this pixel, on the scarcely distinguishable uninhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatred. Think of the rivers of blood spilled by all the generals and emperors so that in glory and triumph they could become a momentary master of a fraction of a dot. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this pale point of light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity and all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we have ever known. And unfortunately, I'm going to run out of time here, and so I'm going to leave you with those thoughts before I show you some more imagery in the next video.